There is a thrill that comes from processing massive amounts of data directly on your own machine. No cloud provisioning, no queuing, zero network lag. That speed is the reason DuckDB has become the engine of choice for in-process analytical querying. It's an engine designed to run inside the host process, rather than as a separate service. It lets you write high-performance SQL queries directly against your local files, specifically targeting formats like Parquet, CSV, and SQLite. If you are a solo developer or an analyst parsing localized datasets right from your laptop, this tool is built entirely for your operational reality. There are no servers to configure, no infrastructure to deploy, and because it runs locally, there is zero cost. By cutting out the internet entirely and bypassing the latency of sending data back and forth to a remote server, DuckDB achieves query speeds that traditional cloud databases struggle to match for small tasks. For isolated, single-player workflows, that localized architecture is extremely efficient, but the design optimizing local speed limits a business as it attempts to scale. The environment changes when you hire a second or third analyst, and suddenly an entire team must collaborate on the exact same datasets simultaneously. The core technical limitation here is how local DuckDB handles multi-user concurrency. By design, it expects a single writer operating within a local process. In a standard hub-and-spoke setup for sharing local files, simultaneous write requests to a central database generate technical conflicts. To prevent corruption, teams rely on manual file locking. This stops simultaneous work, and the team's central truth splinters into isolated data silos on individual drives. When teams hit this collaboration wall, the traditional reaction is to migrate everything over to a massive, complex cloud data warehouse like Snowflake or Redshift. But migrating to a massive warehouse comes with heavy management overhead and high compute costs. For a small to medium analytical workload, it is often severe overkill. This leaves growing data teams trapped between unscalable local files and massive cloud overhead. That specific dilemma is exactly what MotherDuck was built to solve. MotherDuck acts as a managed cloud platform layer that seamlessly wraps around your existing DuckDB setup. Instead of forcing you to choose between your laptop and the cloud, it introduces a hybrid execution engine to bridge local speed with cloud scale. Every command travels from your local environment to a central routing engine. In milliseconds, it evaluates projected latency, transfer size, and cost. Small local CSVs route back down to execute on your machine. Massive shared datasets push up to the MotherDuck serverless cloud. This automated routing happens in the background. It allows a developer to write a single query and let the system negotiate the hardware, drastically simplifying the daily workflow. This image of a balancing scale represents the strict trade-off required to achieve that efficiency. To get the benefits of automated efficiency, the user must surrender manual control over exactly where the compute happens. You have to trust the abstraction layer to make the right hardware choice. By abstracting the complexity of infrastructure away from the user, hybrid execution allows data teams to act like solo developers, even while they operate seamlessly at cloud scale. Beyond execution speed, enterprise environments demand strict governance, security, and access controls that local files simply cannot provide. Local DuckDB relies on whatever basic file permissions your operating system has. MotherDuck replaces that with an enterprise-grade security model. It introduces role-based access control, or RBAC, as a mandatory layer. This ensures that multi-tenant sharing is secure and that only authorized users can query sensitive tables. This matrix maps out the architectural differences. For storage, you move from a vulnerable local disk to managed persistent cloud storage. For concurrency, a single local writer is replaced by multi-tenant sharing, allowing teams to work simultaneously on the same datasets. Adopting this governed, centralized model does mean giving something up. You lose the ability to work entirely offline and disconnected from the internet. But sacrificing the total offline independence of raw DuckDB is the mandatory price of admission if you want secure, centralized team collaboration. Strategically, MotherDuck provides a cloud layer for the DuckDB engine. It adds the infrastructure needed to coordinate across an organization while retaining the core local experience. It provides a serverless middle ground for small to medium analytics. You get team collaboration without the administrative overhead of spinning up a Snowflake or Redshift cluster. This decision tree charts out exactly how you should choose your path, based entirely on your primary use case. If your operational reality is local ETL tasks, software testing, or solo development work, then you should absolutely stick to the standalone DuckDB engine. Keep the zero-cost local execution and enjoy the speed. But if your reality involves shared analytics, persistent cloud storage, and multiple team members hitting the same data, then the rule of adoption is clear. Do not upgrade until the friction of team collaboration outweighs the simplicity of local files. Once it does, MotherDuck is the logical next step.